Assalamualaikum and hello students. In this topic, you will learn about matrices. This topic will show you how to use matrices to handle and solve problems in smart and structured way. In this topic, we will cover 3 subtopics. 1.1 is definition. You will learn what a matrix is, the types of matrices, and how to write them using matrix notation. 1.2 Operation of matrices. Here, you will learn how to add, subtract, and multiply matrices. We also explore special matrices like the zero matrices and identity matrix. Last but not least, we have 1.3 Solving systems of linear equation. In this subtopic, you will learn how to use matrices to solve linear equations using matrix methods. By the end of this topic, you will understand how matrices are used in both mathematics and real life, including fields like computer graphics, coding, and data science. Let's begin. Welcome to our first lesson on the topics of matrices. We will start with subtopic 1.1, definition, and subtopic 1.2, operations of matrices. Before we jump into the lesson, please take a moment to complete a short induction activity. It's designed to activate your prior knowledge and get your mind ready for learning. Definitions of matrices. Learning outcomes. At the end of the subtopic, you should be able to identify matrix and its properties. What is matrices? Matrices is a rectangular array of numbers, symbol, or expression arranged in a rows and column enclosed in a bracket. In this subtopic, you will come across several basic terms. A matrix is made up of rows, that is horizontal lines, and column, that is vertical lines. Each value inside the matrix is called an element. The order of a matrix tells us how many rows and columns it has, written as rows times column. There are also different types of matrices, such as row matrices, column matrices, and square matrices. Understanding these terms will help you as we explore the topic further. In a matrix, a row is a horizontal arrangement of elements. Each row goes from left to right. The number of rows help define the size or order of the matrix. For example, in this 3 by 3 matrix, there are 3 rows. In a 3 by 3 matrix, there are 3 columns, and each column is a vertical arrangement of elements. This means each column has 3 elements going from top to bottom. Columns help define the structure or order of the matrix. So, a 3 by 3 matrix has 3 rows and 3 columns. There are several types of matrices you will learn in this topic. A row matrix has only 1 row, while a column matrix has only 1 column. A square matrix has the same number of rows and columns. An equal matrix means 2 matrices has the same dimensions and all their corresponding elements are equal. An identity matrix is a special square matrix where all the diagonal elements are 1 and all the other elements are 0. A transpose matrix is formed by switching the rows and columns of a matrix. It is written as A with the superscript T. Let's go through some examples to better understand what we have learned in this lesson. To identify the order of a matrix, you count the number of rows and columns it has. the order is written as row times column. For example, for matrix A, the answer is 2 by 1, matrix B, 3 by 2, and matrix C, 2 by 3. This tells us the shape and size of the matrix. Next, state the order of matrix P and B. Matrix P has 1 row and 3 columns, so the order is 1 by 3, while matrix B has 3 rows and 2 columns, so the order is 3 by 2. Here is an example about matrix elements. Given the matrix B is 2, 5, 0, 3, and 6, 7, identify the elements of B22, B31, and B12. This matrix has 3 rows and 2 columns, so its order is 3 by 2. Now, let's identify the following elements. B22 means the element in row 2, column 2. The value is 3. B31 means the element in row 3, column 1. The value is 6. And B12 means the element in row 1, columns 2. The value is 5. Now, let's move on the next subtopic, operations of matrices. In this subtopic, we will learn how to add, subtract, and multiply matrices. You will see how this operation follows specific rules and how they are used to solve mathematical problems. Learning outcomes. At the end of this subtopic, you should be able to identify the various types of matrices and operate matrices. Operations of matrices involve performing basic mathematical operations like addition, subtraction, and multiplication on matrices. These operations follow special rules and can only be done when the matrices involved have compatible size. Learning these operations is important because they are used in solving equations and real-world problems in areas like science, engineering, and data analysis. Matrices only can be added or subtracted if they have the same order, which means they must have the same number of rows and columns. To add or subtract, just match each element in the same position from both matrices and perform the operations. Let's look at some examples of matrix addition and subtractions. These examples will help you understand how to match and calculate the element step by step. This one is for addition of matrices. Here is an example of matrix subtraction. We subtract 2 matrices by subtracting each element in the same position. Remember, this can only be done if both matrices have the same order. Now, we will continue with the multiplication of matrices. There are 2 types of matrix multiplications. The first is scalar multiplications, where you multiply every number in the matrix by the same number. Here is an example of scalar multiplication. Follow the steps carefully. We will now focus on the second type of multiplication, known as matrix multiplication. In matrix multiplication, 2 matrices are multiplied together, but this is only valid if the number of columns in the first matrix equal to the number of rows in the second matrix. The resulting matrix has a different order from the original ones. The diagram illustrates the concept of matrices multiplication. A row from the first matrix is multiplied with a column from the second matrix to produce a single element in the resulting new matrix. Here is an example to show how matrix multiplication works. That's the end of subtopic 1.1 and 1.2. Well done! Next, we are moving into subtopic 1.3, solving of systems of linear equation focused on matrix inversion method. Before that, please complete the learning task and formative assessment provided. Good luck and keep learning!